So we'll go ahead and get started. So this talk is Microservices, the good, the bad, and the ugly. I am in a semi-unfortunate position to be the fourth microservice talk at the conference. And several people have been through some already, so there's probably the bar has been set for what I have to do. And then this is the last talk of the day, which is kind of cool, but also I imagine people are kind of ready to go. So we'll try to get out of here. Probably seen this slide before that conference, and then the sponsors. This is a really big deal. Without sponsors, obviously, this sort of thing doesn't get to happen. As a speaker, get to travel to a different place, come to a resort, which is pretty cool. I'm from Tennessee, from Memphis. That's a pretty big deal. So without sponsors, none of this exists. So if you haven't already, stop by the booth, say thanks to the sponsors, talk to them, and just kind of show your appreciation. So the joke for this, for me, is I came up with the title of Microservices, the good, the bad, and the ugly. I had no idea that was an actual movie. I just thought that was like a phrase that people use. So I started searching for if there were any images that were relevant to put on here, and it was like Clint Eastwood, this movie. And I was like, oh, that kind of makes sense. So again, typical millennial, didn't know that was a thing, but it worked to help me come up with the title of the talk. So my name is James Quick. I consider myself to be three things. Developer, first and foremost. I'm a full stack developer and architect at FedEx Services in Memphis. Also speaker, so I do speaking events across the country. Really enjoy getting out and being able to contribute and then interact with people doing the speaking side of things. And then also teach. So I've been teaching a boot camp at nights in Memphis for brand new developers, which is really, really exciting. I've done a lot of the combination of speaker and teacher as an evangelist for Microsoft for several years and realized I was kind of missing this kind of interaction. So I've gotten back into this about the last year or so of doing more conference talks. So what we're going to talk about, we're going to talk about some real world experience with microservices. What we're not going to do, we're not going to focus on specific languages or frameworks. We're just going to talk about ideas and concepts and diagrams and things like that. Really want to focus on things that you may not have thought about. You hear the pitch about what microservices are, what the benefits are. You never really hear what the downsides are until you get down that path and you have to figure them out the hard way. So I want to kind of set those expectations by covering basically the good part of microservices and then the bad / the ugly parts. And I'll throw in a couple of what I call story times. This is just kind of a real world, this is what happened at work story to share with you. So I know what you're thinking. You're super excited, 2:30 in the afternoon, ready to go home. So we'll go ahead and kind of dive in. But before we do that, we'll start off with a little bit of background. And background in this case is, first and foremost, where did this talk come from? What kind of encouraged me to do this? And where it came from was creating or rewriting an existing application using Java, Oracle. Decided along the way of kind of starting to rewrite that we wanted to move to microservices. It's a big buzzword that we've been throwing around at FedEx, and we decided to go ahead and jump on board and do that. And the biggest learning that came away from that was development took considerably longer. I think I have a typo in here. And a lot of existing work, I think I deleted a line, sorry, had to be rewritten to adopt the microservices architecture. So not only did we have to learn things along the way, we had to change how we did them from the past. And in general, that took a lot of time and a lot of effort and a lot of learning. I just want to kind of raise awareness to everyone here about those things. So I have a talk that I gave recently about CI/CD. It's a culture shift. And one of the things I talk about is the fact that when you get a pitch for some technology or framework or architecture or whatever it is, all you hear are the positive parts. So you think about waterfall versus agile. How many people are agile now? How many people are waterfall? And everyone like crosses their fingers and like shuns away from those people, right? So we've made this big transition to agile, and you got all the promises of what agile is and the downsides of waterfall, but there's actually some benefits to waterfall. It's not all just one way or another. In waterfall, you know exactly what you're going to be working on because you've got all the requirements for a project. As a developer, I come in, I do my work, I know what I'm supposed to be doing. There's no ambiguity. Agile, that's not necessarily the case. You're kind of figuring it out as you go, and from my perspective at times, that's been a real struggle for me. So the overall theme here is going to be, you hear a pitch, oh, everyone should do this new thing, this new buzzword. It's never the case that it's actually perfect, and we just want to try to lay those expectations for what you can expect. So thinking about microservices, where did we come from first? We started with monolithic applications. You break this into two different roots. You get mono and lithic, and literally means one stone. So you have one application, You look to deploy that application. You take that whole thing, one deployable asset, a jar file or a set of files or whatever that asset is, and you take that and you put it on a server, and that's basically what you got. You can take that one step further for a little bit of kind of organization where within your monolithic application, you can start to break things out into modules. So you've got these really clean-cut modules inside of your application, but at the end of the day, it's still one deployable asset that actually goes out there and gets deployed on a server somewhere. Microservices is going to change that a little bit. This is an architectural pattern where you break an application up into many independent services. And one thing we talked about before we got started for just a second is microservices doesn't necessarily mean small services. Usually it kind of becomes that, but it more means you're doing like one business unit or one business functionality per service, and you're kind of isolating that part from other pieces of an entire application. So it doesn't necessarily mean small, but because of that isolation, that usually does become relatively small. So think about microservices. You got a bunch of different pieces. You start adding them together, you get more and more little fishies. And at the end, you kind of create something with all those pieces. They come together and they create something. And I think about this picture actually I thought was really cool of ants kind of chaining themselves together to do something really incredible, to fill a gap, that space of 2 to 3 inches or however long it is. And an ant is less than a centimeter, however long they are individually. But together, all those many pieces working together, I kind of relate that to microservices, where all of these different services coming together to create one application, one common goal. So in how we actually, let's say we've got 4 different services. We want to deploy those to a server. Well, we'll take one, we'll put it out there, then we'll take the second one, then the third one, then the fourth one. And these are still completely individual components that interact with each other to then be able to do some stuff. And there's lots of implications behind this model, which is what we'll talk about going forward. But just want to raise a little bit of awareness to how microservices, first and foremost, are being used now. And they're being used by really top companies: PayPal, Amazon, Twitter, eBay, Uber, and Netflix. I don't think my it jumped. Clicker's not working that great. So a lot of top companies are using microservices just to kind of prove to you that it is a viable option if used in the right way and kind of understanding what all comes with it. Now, one thing I want to highlight about Netflix specifically, I hope this doesn't act up the whole time. Netflix is actually pretty active in the open source community for packages that help facilitate the creation of microservices, specifically in the Java Spring Boot framework, which is what we use at FedEx. So just want to kind of highlight a couple of the pieces that are in this I'll talk about just in terms of how we use them, but won't get too specific down into the Spring Boot realm. This will be just more generic microservices in general. So I want to talk about the ilities with microservices. This is how we're going to divide this talk up, and you're probably looking at the ilities. Maybe you've heard of them, maybe you haven't, and you're like, I don't know what the hell that is. A little bit of background for this is kind of a later on thing if you want an article to read, and I've got links to the slides that I'll give you when we're done. There's an article I read in kind of prepping for this of 5 major benefits of microservices. You organize around business capabilities. Again, micro doesn't necessarily mean small. It means kind of specific to these business capabilities. You get improved productivity and speed. You get flexibility in technology and scalability, automated cross-function or autonomous cross-functional teams, and they're easier to build and maintain. And so having been through the experience of adopting microservices and all the things I've learned along the way, I read that and I kind of laughed a little bit. I was like, well, like this is one of those things that sounds great, but in reality, there's just so many things that aren't being considered and just here's the 5 benefits that it just doesn't quite work out that way exactly. So the ilities, coming back to that, we'll go through a scalability, isolatability, I'm pretty sure I made that word up, testability, deployability, maybe I need new batteries, I don't know, reusability, and stability. So we're going to go through each of these ilities. We'll talk about the good parts, and then we'll talk about some of the negatives, the bad and the ugly, and kind of compare and contrast those. And that's what we're going to walk through with the 33 minutes that we have. All right. So we'll start with scalability. And a good kind of story to think about is think about the holidays. Think about Christmas. What do you think about? You think about food and family and giving. And if you're honest with yourself, most importantly, you think about presents. It's fun to give, but it's also fun to receive. So Christmas time, people are out there buying presents. On Black Friday, people are going to Best Buy and Walmart and going on Amazon.com, and they're all trying to buy electronics, right? This has a really big impact on companies like, again, Amazon, Old Navy for clothes, Target for basically anything, Best Buy for electronics, Toys R Us for the kids, and Walmart just for about everything as well. This clicker's killing me. So there's some really big implications with Christmas and Black Friday and all these other holidays for all of these companies, including companies that then have to support those other companies like USPS, UPS, and even FedEx for shipping those things that get ordered online. So in this scenario, what do all of these have in common? They have a need to scale at different periods throughout the time. How many people work at a company where peak season is a thing? Talk about peak. Right, that's a big thing for us at FedEx. Christmas, Mother's Day, Valentine's Day, all the different holidays are big deals for us because we have to all of a sudden scale our load to a much bigger capacity than what we're used to on a regular basis during the year. So then you start to think about, well, okay, I understand I have to scale, but how do you actually scale? So we'll start with a monolithic approach of, let's say you've got your app, it's running on a server. It's got 6 gigs of RAM, 512 gigabyte hard drive, 2.2 gigahertz CPU, whatever you got. You got some sort of server. And if you want to scale up that monolithic application, really you just buy a bigger box. Now you get a 32 gig RAM, you got 2 terabyte SSD, you got 3.2 gigahertz CPU. You really just scale that box up. That's more or less what you're limited to. And what that means is that those monoliths are going to scale vertically, whereas microservices do something a little bit different. So let's start with, we've got 4 different microservices, S1, 2, 3, and 4. If we want to scale these things, we just add other instances of those microservices. So now we have 2 of each. If we then only need to scale S1 and S3, we add a couple more of those. If then we need to scale S3 one more time, we add another instance of S3. And we might even need to add another one to support whatever the load is. If you think about during peak season, during ordering season, if this was a shopping cart service or an ordering service, that S3 at peak season is going to go up really high, right? Whereas the other services think about Amazon, like streaming video or music, doesn't necessarily correlate to the drastic jump that you'll get in orders coming in. So microservices are going to scale horizontally as opposed to vertically. And there's a little extra reading, again, later on if you want. Article called Scaling Monoliths versus Microservices, and it actually gives a pretty honest approach to kind of the idea that people sell scalability for microservices and what that actually looks like. And it's probably a little less of what you'd expect. So just kind of extra reading, if you get the slides later on, might take a look at that. So then the question, after you know I have to scale, in theory I know how to scale, the question becomes when. And there's lots of different ways you can do this that become really useful if you take advantage of some of the cloud capabilities that we'll talk about in a little bit. Automatic scaling of your instances of services based on maybe CPU usage. If your CPU usage crosses a certain threshold, or if your RAM crosses a certain threshold, or the number of requests coming into your service crosses a different threshold, you can automatically scale those things out. You can also kind of choose to manually scale up services during a certain period of time. So the 3 weeks before Christmas, scale up all of your services 2 or 3-fold, whatever you need to support the load that's coming. And when it's done, you just kind of shut that thing down. The difference of kind of scaling vertically with monoliths is when you have this, you have basically a server. If you exceed the capabilities of that server, you have to buy a bigger server. And you have to buy a big enough server to support your load no matter how high it gets, even if it only gets high at a certain period and then goes back low again. Microservices and some of the cloud stuff that we'll talk about in a little bit, you really have the ability, the flexibility to scale individual pieces whenever you need them and scale them back down when you're not using them. So isolatability, again, pretty sure this is a made-up word, but it kind of fit what I needed at this point. The thing about microservices is that they're independent, and if the audio was Kelly Clarkson, Miss Independent. Yeah. Anyway, Microservices are very independent. They work independently. They can be developed independently. They can be tested independently. And then they can also be written independently. And so a lot of places will preach, and this is something, the seven ways to fail with microservices that he talked about yesterday morning as well. There's flexibility of language and framework. So in theory, if you've got all these different microservices out there, you can use whatever technology fits the given team that you're working on or the specific need of that application. You could use Java, you could use Node, you could use .NET Core, whatever you want. And in theory, all of this stuff will really work together. It's not necessarily all the case all the time. We'll come back to that in a second. So first story time of today, we had an intern and 2 brand new entry-level developers join. I guess it's been maybe two months ago, and about the first week of June. And their task coming in was to create a new service that would interact with other services that we already had existing, get some information from them on a polling basis, and then send that information out to some other consumer. And this was this actually was a really good benefit of microservices. They could start with a very incremental approach. They had to go through and kind of learn what microservices were and learn how to create them just from scratch, just like basic tutorials, right? They had to do that because they never touched or seen anything about microservices before. So after they got a little bit comfortable with just what it looked like from a development perspective, they actually created a new repository. They created a new service that got checked into that repository. And they were able to just run that service independently and see that it did a couple of the things that it was supposed to do. Again, they got like an overview of this overall application, but they've never seen any of the other code from the other services because at that point they didn't have to. After they got that they were comfortable with what they had, then we started talking about how to integrate with another service, how to talk to another service. Didn't have to look at the code for that service, didn't have to understand what was going on in that service. Are they done already? All right, just to make me feel better, when I say something good, you guys clap too. That'd be nice. Hey, I appreciate that, yeah. Maybe we can have a little back and forth, I guess. All right, so back to the process. So after getting comfortable with what a microservice was, after learning how to talk to another internal microservice that we had, they didn't have to learn everything about all those other services that they didn't touch. They were able to create a brand new microservice, checked in, deployed to production, connected to existing microservices, and sending information necessary downstream. So I've got a lot of bad and ugly of microservices, but that was a pretty damn cool story for 3 brand new developers, one being an intern, to be able to step into a brand new architecture, brand new code base, brand new work environment, and be able to ship something to production in a month and a half or so. That was actually pretty cool. If they were here, I'd let you clap for them. So there's one big problem with all of this isolation, though, and it's communication. How do these things talk to each other when you start breaking them out from each other? So we look at how things communicate in a monolith. There's not really anything to it, right? Part of your code just calls another part of the code, and there's no complication, there's no overhead, there's no extra. That's just kind of what you're used to. That's what it does. You get into microservice communication, and it's not that way. You've got all these different services, S1, S2, S3, S4. And keep in mind, this is just for demo purposes. Scale could be 20, 30, 40 microservices, right, which gets really unwieldy. But for these things to talk to each other, they have to know how to make requests to each other. Typically, communication is going to be over REST if you're looking for a response for the request that you send over. So you make a REST request. This means that S1 needs to know the URL or the path to get to S4. This means for S2 to talk to S3, it has to know where S3 is. This means S3 has to know where S4 is to make that request. So there's a lot of things that you have to inject into these different microservices to have them talk to each other. And that's just with one instance. You start to take advantage of scalability of services. Now you've got two instances here, 3 here, 15 instances of another service. And now if you're looking at trying to get S1 to talk to service 4, how does he know which one to talk to, right? You have to know at this point, we're talking about each individual service has to know the paths, the URLs for each instance of the other service that it needs to talk to, and then needs to figure out how to load balance those requests so that you're not just hitting one instance of a service. Otherwise, having multiple instances is doing you no good. So at this point, communication in microservices actually gets very complicated. in come Netflix, especially in our area. Netflix created these open source packages called Spring Cloud, and these are different packages that help facilitate building cloud native microservices in Spring Boot. One of them is called Eureka, and it's so right up there, Eureka or Discovery Server. And the way this works is you have all of your different services out there in the same way. You deploy this discovery service. When each of your services starts up, it registers itself with Eureka. And this means from now on, if Service 1 wants to talk to Service 4, it asks Eureka or the discovery server, hey, I just want to talk to Service 4. Go and take care of getting there for me and then give me the response back. So you're not having to have multiple services, keep track of multiple instances of different services, and do the load balancing. This middleman will do all that load balancing stuff for you. Technically, there's a little more that goes on to facilitate that from the Netflix package side, but most of it comes through the fact that Eureka keeps all of the configuration for where all the different instances of servers are. This means that if we then add another instance of Service 2 up there, no one else cares. They just know I go to Eureka and I ask for Service 2, and it routes me in the appropriate way to the appropriate instance of that service. And so you start to really take advantage of that scalability through using something like a discovery service. So that's the good part. That's actually really cool when you have that in place. What if your framework doesn't have a discovery server or service package already existing? What if no one's done that work for you? That's a lot of work. There's a lot of functionality that actually goes into that one specific thing, and if that doesn't exist, that's on you to figure out how to do it. Otherwise, your communication at scale becomes very, very complicated. Another downside is it's an extra service, so you have to have this checked into a repository, you have to have this be deployed, you have to have it running when you're testing. It's another service that you have to add to your suite of services. And then you think about different languages and frameworks. We talked about they could be independent of each other before, or when we started this section. But that's not quite true if you're registering with a discovery server that only supports Spring Boot application and it facilitates that routing and load balancing to different services. If you then jump in with a different .NET Core or Node or whatever it is, that may not fit in nicely with how to go through that communication bridge in the discovery server. So there's complications with trying to add in that. In addition to, I think you mentioned yesterday, just team-wise, if you're using every service that you have across different teams is different, you've got a supportability potential issue, right? I don't know how to support a .NET Core application or service. There's scalability in terms of how you get your teams to work on different services, or movability or whatever, I don't know, some kind of ability to get people to work on different services. There are extra complicated things that come along with that. And one last thing real quick.
Does that also introduce a
single point of failure if the Eureka part? It does, yep. So that is one of the downsides as well. If Discovery Server goes down, you've got issues because they can't find each other. Yep, exactly.
They have a high availability setup for that probably, right?
We haven't had any issues with Discovery Server, so for what it's worth. But yes, it's definitely worth noting and thinking about. Yep. Yeah, and I'm not the one to speak on load balancing specifics, but I will tell you the fact that you're having to bring that conversation up reinforces the fact that it's an issue that needs to be solved, right? I think that's the main thing, at least for me. But I don't know networking and load balancing that well, so I don't want to pretend to try to go into detail with you. All right, testability. It's a really cool quote that I found. You have to actually test to take advantage of testability, of the benefits of being testable. Anyone heard that quote before, know where that came from? That was me. So if you had, I'd be surprised. I'm going to probably try to...
Only because you might skip the slide.
Did? Oh, I did. Yeah, sorry. Thank you. All right. This is actually a really short one. Just talking about communication, everything that I talked about was REST. You could do asynchronous messaging between services using some sort of queuing technology. I think this was a Kafka diagram, just to raise awareness that I'm not completely ignoring the fact that there's another form of communication that you can use. Thanks. Yeah, good catch. All right, and I didn't do my joke that well. So this is me. I'm the famous person who made this quote. So when you run your services locally, you just think about testing. When you develop a piece of code, you run it locally to see if it works, right? Before, when you had a monolith, you start up that monolith and you do whatever you need to do, and that's the one thing that you need, or a test database, or whatever supplementary things that are out there you need. You start it up and you go. Now, when we're talking about microservices, there's a couple of extra things that you need. You need a discovery server. You need a config server, which we haven't talked about for doing external configuration. And then you need all of these different services. So if you're trying to run code on S1, you're trying to see if it works. A lot of times it will have dependencies on talking to other services, which means just testing that part actually means you have to incorporate and run all these different services. And that literally means run service 1, run service 2, run service 3, so you have them all up and running to simulate that full environment. Another level of testing. This is actually, in theory, one of the really good parts of this is you really can completely isolate the stuff that you do. And this goes back to the story of, call it Team BLB was their name, the intern and the 2 new hires. Working on the project that they didn't have to worry about all the other services. They could just work in one to get started and then figure out how to integrate. So you can have, between your 2 different services, you can have specific tests just for those, not worry about the other ones, and take advantage of that isolatability. But to do that, you end up having to do a lot of mocking. So because you're not talking to another service, if you have a dependency on requesting something from another service, you have to mock that up. And that actually adds a lot of complexity into writing your tests, is to mock all of those things up to try to really get dedicated to your unit tests. And then you get an integration test. This is a really interesting one for me. To do integration tests with services, especially at scale, you have to, 1, make sure all the services are running. You have to, 2, make sure that they start in a certain order. And what that means is if you start an application and it's dependent upon configuration from the configuration server, but configuration server isn't running, this service can't start. Same thing if Eureka is not running first and it can't register with Eureka, depending on how your application is set up, your application might fail then and there too. So not only do you have to have all of your services running to simulate this full environment, you also have to start them in a certain order. You have to go in and do all of your initializing database records and then clean up after. You need specific test levels of servers and DBs and queues and all this kind of stuff. And honestly, I'm still at a point at work where full integration testing with all these services is a little overwhelming. It kind of blows my mind about how we put all that stuff together. And we've done things that are moving in the right direction, I think, but we've still got a lot to figure out, and I personally have a lot to figure out. So just want to kind of raise awareness to when you start to put all things together after being broken apart, there's a lot that goes into it. Another famous quote, this one's by me too, is plan on failures, code for them, and test them. Especially when we talk about that communication between services, talking REST specifically. If you fail to make a request to another service, or your request times out, or whatever it is, you have to handle that. You have to know what to do so that your application doesn't just stop. And that actually adds a lot of complexity that you didn't have with a monolith, because a monolith just says, call this other piece of code. Now you're making an HTTP request, which also adds network bandwidth that you have to support as well. Something to think about. Deployability. Some of the benefits here. Ideally, you could be hardware independent, operating system independent, and cloud independent. And what that kind of wraps up into, with some other specifics involved, is being cloud native. And there's an article in here for additional reading that you can read later on as well about what cloud native apps are. But they talk about incorporating 4 different things: DevOps, continuous delivery, microservices, and containers. We'll talk about a little bit some of the more specifics about this in a second. But by being cloud native, by being cloud agnostic, operating system agnostic, you can take your servers, or your services, excuse me, and you can deploy those on any cloud anywhere. So you can go to AWS, you can go to Google Cloud, you can go to Microsoft Azure. I work at FedEx, and AWS is starting to ship more and more of their stuff, so we're a little reluctant to put stuff on AWS. So you can imagine, in theory, at any given time, you can take what you have and just lift and shift and put it on any other major cloud platform out there. With those cloud platforms, you get relatively infinite scalability. If you're managing your own data center, that's stuff that you have to be able to support. If you're using a third-party major cloud provider, they can kind of do that stuff for you. And they give you geo-redundancy. Redundancy in this case means that microservices across different regions in the world or the country. If one of them goes down, you've still got the other one. But to take advantage of that, your microservices have to be stateless so that at any given point, if one service fails and a new one starts or a new one starts to get traffic, it has to be able to respond in the same way that any other service would at any given time. And this takes a little bit of kind of a mindset change too in how you do your development to make sure that these things stay stateless. Some of the additional limitations, depending on maybe more kind of legacy applications, you're usually going to be limited to a file system. You probably won't be able to do TCP connections if that's something that you use. And you have that forced statelessness. So some of the things that you might have been used to and kind of expected to be able to do, you might not be able to do when trying to get to a cloud native environment. Now there's ways, especially the file system, you can use like blob storage in a database, or AWS and cloud providers have like optimized file storage that you can interact with on their platform. But it's not going to be the same way that you're used to. So typically when you have deployments, you have some sort of outage. If you've got a monolith, you take it down, you deploy the new whatever it is, and you start it up, and there's seconds or minutes or tens of minutes or hour. I don't know how long deployments take. But usually there's some sort of interruption. One of the cool things that you can do with microservices is you can do zero downtime deployment. So if you've got a service out there that's taking traffic coming in, you can then put a new instance of that service out there but not send traffic that way yet. And then when it's fully deployed and it's ready to go, you can just switch over all that traffic and have zero downtime deployments where you're not affecting whoever the calling applications or customers are. One of the things about this that you can also take advantage of is kind of slowly migrating traffic over instead of just jumping completely. You can start to send a few requests and give a little bit of like testability for that to see if it works. And if you feel good, then shift it all over. But you've got a lot of flexibility with microservices being deployed to take advantage of zero downtime deployments. Another cool thing of this is you can deploy one service at a time. So if I only have a change to one piece of code, I can deploy just that one service or update just that one service. I don't have to worry about the entire application. Potential downtime is smaller if something goes wrong. Hopefully, just the one service is affected and other services can keep on chugging, and then the application continues to work on. You code for that failure, expecting that failure, you code for all that stuff and you protect yourself. And then your application just kind of keeps on rolling, ideally. Some of the downsides, without continuous delivery, without some serious DevOps, deployments take a lot longer. You're deploying at scale 5, 10, 20, 30, 40 microservices, and if you don't have automated tooling to do that, you're typing something or pushing a button for each one of those, that takes a long time without some really good pipeline stuff set up. You've got your extra services, discovery and config server and other ones that you need. And then versioning can be really, really tricky. This can be really difficult. Backwards compatibility, you have other people calling into your application expecting a certain thing. If it changes, you're affecting a lot of people, which we'll talk about in a second. That leads us into reusability. So let's say you've got an application where you do some sort of core logic that other applications could use and benefit from. You could have your big application, S1, this should actually be app, sorry about that. You have your big monolithic application, you've got other apps out there, and you can just kind of open your application up to let those other applications call into yours to get whatever they need. The benefit of this is they don't have to write the code for it themselves. They can just integrate into what you already have. But you run the risk of overwhelming your system. If you start to let other people at any given point send any amount of traffic to your application for just one piece that they need, they could overwhelm that piece, which then overwhelms and kills your entire app. Not necessarily ideal. So remember we talked about scalability and isolatability. These benefits come into play now with microservices. If I want to let other applications call into one of my microservices, if I reach a certain threshold, I could automatically scale up. If that thing fails, worst case, it shuts down, another instance pops up, and it just keeps on chugging along. So a couple of options I want to talk about for deploying that reusability is doing that locally and or centrally. With microservices being fairly independent and being checked into their own repository, there's nothing stopping a team from taking that source code and just deploying that in whatever fashion they need to support whatever their specific needs are. If they've got timing needs, they need a a sub 50 millisecond response and they can't make a request to a data center across the country or something like that, they have the ability to take this microservice and deploy it right wherever they need it to keep those timing constraints fulfilled. The caveat to that, or the flip side of this, and this is ideally the more recommended route, is doing centralized deployments. And this is where you have your microservices deployed in your cloud data centers, geo-redundancy and all that kind of stuff. You got multiple instances and different applications just call in and you take advantage of that scalability. You scale up as you need it, you scale down when you don't. And ideally you can handle that load, and worst case things fail and they start back up and they're stateless, so they run pretty well if you've coded it the right way. With the ability to let so many other potential applications take advantage of your functionality for this one service, there's the risk of that getting out of hand. So many people calling in, so many people having requests, so many people having needs, that can get a little unwieldy. So you need to have an intentional focus on your API contracts. If this service is supposed to do this one thing, you define the ins and outs of that service, what endpoints exist, what responses you think make sense for the general public. And you stick pretty close to that, and you focus on being API first. I don't need to know a whole lot about other applications, but I do need to know what the integration point is, what the API calls that I can make, and what the responses are that I can expect back. How many people you did something cool at work, and all of a sudden everyone else wants to use it? Couple of hands, right? You do something good, other people, and again, there's ideally not a reason for duplication. It happens all the time, especially at big companies, but you want to try to minimize that as much as possible. But this means if I've got this one service, tons of people are making requests to me, I have to have a lot of ownership of that service. One, there's support. There's handling feature requests, things coming in that may not fit exactly with what we think this service should be. You have to kind of push back, and you have to stick to that API first mindset of saying, this is what we do. You have to kind of conform to us for the most part if you want to take advantage of what we have. I'm not saying you shut down everybody, but you have to protect yourself against that scale. So a little bit of story time. We had a service or a couple of services at work, same situation. We had lots of requests coming in, and they were requesting different formats of the same data and different request types and all these different things. And we had this need at work to do that all of a sudden. Within a couple weeks, we had this application needs this data, this application needs the same data, this application needs it in a little different format. And that's the situation that you'll be in, where if you start to take on all of those things, you're going to have people with their specific needs that are unwilling to adapt to what you're willing to provide. And then there's going to be some sort of conflict, but you have to work to protect that this is the way it should be, and especially at scale, you've got to think about all these people asking what really makes sense in terms of how you respond. One thing that would really help with that is API documentation. So how many people are using some sort of like formal API documentation system? This is something we have a long way to go at. We've really struggled with this, and we've had different conversations about different things. But when you're talking about exposing your application or your services to other applications at scale, you don't want to have emails of people asking you what to expect when they call it, what an endpoint is, or what kind of data to respond back with, like sending JSON in an email. Like that's not the way this should be. So you might have to invest monetarily and time-wise and whatever else to get some sort of actual documentation tool to help standardize all that stuff across the company. Something like Swagger. Anybody using Swagger? That's usually the biggest name that comes up. I know there's lots of other ones. But just something to keep in mind. So just remember, with microservices, always recycle your code. So I think last section I think is stability. So with your applications, especially taking on potential extra load, you don't want them just kind of walking around and falling over. Eventually you want to make sure that these things are able to continue to run no matter what happens. And one of the things that I'm really passionate about is manual intervention should not be a thing as much as possible. So what I mean is, you don't want when something goes wrong, somebody gets on the computer and they're changing database tables and they're restarting applications and they're changing configurations. That's not the kind of thing you want at 3 o'clock in the morning when something goes wrong, right? It's also from a developer's perspective, not the thing I want to do at 3 o'clock in the morning if something goes wrong. So in general with stability, no manual intervention. Try to automate and plan for these things as much as you can beforehand. It'll save you a lot of time and potentially sleep later on. Design your code to handle failures. We didn't talk about this, but there's circuit breaker concepts where you can have, if a service is trying to call another and it fails, or it fails a couple of times, then you can have basically a totally different function of what to do when that fails. So you've already coded and planned for, this is definitely going to fail. Now how do I handle it gracefully and have my application continue to move on? A lot of this comes in with redundancy as well. This is actually a copy of the redundancy slide before. But if you've got your services, multiple instances of services, and they're geo-redundantly deployed across data centers across the country or the world, doing it again. I'll give you a chance to clap in a second. If you're taking advantage of deploying these in such a way across data centers in the world and taking advantage of being stateless, your microservices can and will go down almost constantly, but they will recover if you do it the right way so that you don't have to manually get on a computer late at night and start typing in configuration changes and database changes and all that kind of stuff. Anybody do a database change in production recently? Probably don't want to admit it. Yeah, a couple hands. There you go. One thing that comes along with this too is a need for alerting and centralized logging. If you've got all these different microservices out there, something's wrong, how do you track it down? I think, and I forget the guy's name who did the talk yesterday, but he kind of touched on this too. You want to be able to be notified if something goes wrong. Ideally, your application takes care of it, but probably not initially because you're figuring stuff out. You want to be alerted, and then you want to have some sort of way to figure out log statements in the kind of old way we would do it. You'd probably go into like VI and look at the logs and do a grep and try to find the specific lines that you're looking for. There's a lot of tools out there to do aggregated logging from all of your services and give you a GUI interface to be able to search in an easy way. For these kind of things, AppDynamics, Sentry, Splunk are a couple of the companies that kind of fall in here. Downsides of this, one, you have to think about how to handle your failures when you're calling other services. Making those REST requests, they're likely to fail at some point, so you have to plan on that. That's something you didn't necessarily have to plan on as much in the past. The overhead of REST, this is kind of a simple thing, but your network bandwidth, can your network handle the additional requests that are coming in and out that it didn't expect before? It's something it's easy to overlook, but can certainly have an impact on your applications. Have to invest in some tools to do the tracking and alerting, those kind of solutions. And from personal experience, they aren't always perfect. We used one of the centralized logging systems and tried it out and really quickly couldn't find log statements that we expected to be there. And with that being the case, we can depend on that with being our centralized logging solution, because if we have to find root cause for something, we have to have all the logs that should be there. Otherwise, we're kind of screwed, right? So investing in researching those tools, then investing monetarily to get them, and then hopefully they work the way they should, that's a lot of work. So just to wrap up, I want to leave you with a couple of open questions that I've got in terms of best practices. We use something called a database service, and this is everyone that needs something from our database and our application will come to this one service, and it's the only one that actually talks to a database. The reason for this is if we make database changes, that only needs to be reflected in this database service. No other application needs to be affected by that. A lot of diagrams you see talk about having a database per service so that they're completely isolated. This does cause us to have, if you need anything from a database, one service needs to have the database service running. So there is that dependency, but it's worked out fairly well for us. But in terms of like at scale, is it really the best way? I don't know. REST communication versus messaging of some sort. There's typical general kind of guidelines on when. If you need a response, REST makes sense. If you're just trying to push something out there and somebody else will process it, queuing messaging system of some sort makes sense. But figuring out where those lines are, that can be a little tricky. How finally do you break up your microservices? I think everyone's got this question. Where do you actually draw the line on what a microservice is, how big it gets? What are the best tools? We're still doing investigation. We've still had issues with some of the tools that we've tried out. It's a ghost. And then API version management, with having different services out there on different versions and then allowing reusability for other people to call into your services, this is actually a really big deal, and it's really difficult to track if you don't start early on. And that's something we've got a lot of work to do on as well. So just in recap, what's the good about microservices? It's all the LDs. It's scalability, deployability, testability, isolatability, stability. Is that all? That's 5. There's 6. You guys got to pay more attention. The bad, about this, I think my batteries must be dying. The bad, it's the overhead. It's how much work it takes to get there. You get this promise of what microservices offer you, but it takes so much work to do all these different things that we just touched on that you have to come in with a mindset of things are going to be more difficult and your production is almost definitely going to slow down, especially initially, and then eventually ramp up later on to take advantage of all the things that people say you should take advantage of. And then the ugly for me is those false expectations. It's people at a high level throwing out buzzwords. It's people hearing a buzzwords and saying this is the way we need to go, not understanding the situation, when and where to use them, what the implications are, the work that goes into it. That's the thing that kills me, is not having a really good understanding of what you're getting into before you go down this path. And I don't think we necessarily had that. I think we got down this path and we had to figure a bunch of stuff out, like I assume most people do. But I just wanted to raise awareness to some of this stuff so that you have an idea if you're looking to do this or if you're already doing it, things that you can consider going forward. Last couple of things. I have a talk called CI/CD, It's a Culture Shift. This talks from a similar approach about all the implications of adopting CI/CD, the things that actually have to change and what expectations can be on your end, especially from a cultural perspective. It's in the slides, so if you're interested in seeing that or checking out that talk, it's on YouTube. I also run a platform called Learn, Build, Teach. I do YouTube videos and online courses and blog articles, primarily on web development, design, and developer tools. If you're interested in that, learnbuildteach.com. You can check that out. I've also got Learn, Build, Teach stickers. If you're interested in one of those, come see me after. I think I've got 50 with me. So unless everyone wants one, we should have enough if you want it. So come up after. Did I move this out of a... Keep in mind that conference, August 3rd through 6th next year. I have had a blast since I've been here. Got to go to the water park last night. That's a lot of fun. I will definitely apply to be back if they will let me. I will be back, and hopefully I'll see you next year. So the slides you can get, I just kind of updated my personal website to be able to have a list of all the talks that I've done. I've only put one in there, which is this one. So if you want the slides, you can go to jamesqquick, my personal website.com/talks. Don't judge me too much. I haven't spent a whole lot of time styling this thing. I was working on it the hour before I came in here to give this talk. But the link is there to get to the slides if you want it. If you don't see it, you can ask me on Twitter at jamesqquick. I also updated a link in that conference description to the slides as well, so you have access in multiple different ways to get this. You guys have got 4 minutes or so. Any questions? And again, I'll stick around for a few minutes if you have some extra ones. Yep. Someone gave a talk about that, right? Like yeah, I have no idea what that means, to be honest. So no, not at all. I was really curious. I think I ended up choosing a different talk, but someone gave a talk on that one, and I'd be curious if someone wants to kind of enlighten me after. I'd love to hear about it. Yeah.
When building on microservices, and you have common information as far as one thing was like a registration process, and you have information that's going to be common instead of going through all different microservices. How would you go about getting that information to all the services? Would you have the application call each individual microservice? Would you have the application call one spot where that will sell to other microservices, or one microservice to cause another microservice? What type of flow would you expect to see?
Yeah, so the question is kind of service to service, needing information from different services. How do you approach who to call and when to call and that kind of stuff? I think a big answer to that is the discovery server that we use. So because we can scale our instances out at any time and everything registers with Eureka, we can go through there and just say generically I want to get to X service, and it will do all of that routing for me. We do, for requests that come in through our front-end application, we don't let the front-end application call different services directly. We funnel it through basically a GUI service, and it then distributes all those requests out to the specific ones that need to happen. I think we've been fairly happy with that so far. So that's kind of like almost like an API gateway kind of thing where it comes in and then it gets rerouted out. But in some ways it seems silly, right? Because you're making an additional request to do something that the front end could do directly. But it's more standardized because we do relative paths and everything. So it just calls the back end and it distributes it out. So that I think we've been happy with. It does seem a little odd, I think, at times. I think the database service thing might seem a little odd. Again, it's been pretty positive for us. But I think there's a lot of like real best practices that we're probably still figuring out too. Anything else? Yeah. We will. So we're using PCF right now, Pivotal Cloud Foundry, and they kind of manage all the containers and that kind of stuff for us. There's a team, and the ground team is actually doing some exploration into container or Docker and Kubernetes, and I haven't been directly involved with that, but I know there's a lot of investigation going on to see if that's the way that we want to go. Yep. Have a good one, guys. All right, I'm going to wrap up. If you have any other questions, feel free to come up. I'll stick around for a few minutes. And thanks, everyone, for coming. I really appreciate it.